In another video, I showed how to create an involute gear using a technique from PTC's Knowledge Base. There is another technique that is available that allows you to create another gear, but this one with helical teeth. Let's take a look at how to do this technique. I'm going to start off by creating a new part, and I'm going to call it gear helical. I'm going to uncheck use default template just to make sure that I am using my standard start part. Let's turn on our datum plane visibility. The first thing that we're going to do is create some different parameters that are going to be used to control our gear. To go to our parameters, I'll use the model intent overflow menu and then choose parameters. And here are the ones that came over from my default template. I'm just going to make this a little bit wider and a little bit longer. Let's start creating our 4 main controlling parameters. Let's hit the plus sign. And the first one is going to be for the thickness of the part. And I'm going to turn on my caps lock. Thickness. And this will be a real number. For the value, we're going to start off with a value of 20. And we have a column over here for the description. Let's fill in this information as well. And this is going to be the face width. For the next parameter, it's going to be the number of teeth. And I'm going to deviate from the procedure and change the names from what they have there. I like my parameter names to be really intuitive. And so the number of teeth for this one, we're going to have 16. Let's hit the plus sign to create another parameter. This one is going to be for the bevel angle. And it's going to be a real number, and we're going to use a value of 20. And the last one that we're creating for controlling is going to be the module. And you can think of the module as the tooth size. And let's use a value of 4, and just FYI, if you multiply the module times pi, you'll end up getting the pitch of your gear. So this is good for our 4 controlling parameters. Let's click the OK button to get out of here. Now we're going to start off making our main protrusion. I will sketch on the datum plane called front. And for this one, I'm just going to make a circle. Snap it to our intersection of our sketch references. I'll initially start this out with a diameter of 30. I will hold down the right mouse button to get out of sketch mode using the check mark. And with the sketch still selected, I'm going to extrude. Let's right click over the depth drag handle, and I'm going to change this to a symmetric depth of 20. And we did create a parameter called face width in a moment. We're going to use some relations in order to control this. I can hit the middle mouse button to complete the main protrusion, and right now I don't need to see my datum plane, so let's turn off their display. The next step is that we're going to write a whole bunch of different relations for controlling our different dimensions and parameters for the gear and the gear's teeth. So let's go to the model intent overflow menu. And from here, I'm going to choose relations. By the way, relations is a command I use so much, I've got it in my quick access toolbar. And again, as before, I'm going to make this dialog box wider. I'm going to scroll down over here just so I can see the names of some of the parameters that I already created. And here my part already has a relation in here for creating a parameter for the weight. Let's start off with a comment line. Any line that has a forward slash and an asterisk is the comment line, and I'm going to define the pitch radius. And here the equation is going to be, and I'm going to make pitch radius as the name of the parameter. This is going to be the number of teeth, which is teeth, and we're going to multiply by the module divided by 2. Next one is going to be the pressure angle. And we're going to call that alpha, and that's going to be equal to a value of 20. Next one is going to be the involute of the pressure angle. We're going to call that EV alpha. And this is going to be the tangent of alpha. And by the way, I like to use a lot of spaces when I'm writing relations to make them easy to read. And we're going to subtract pi times alpha divided by 180. And this pi times alpha minus 180, that's essentially a conversion of the pressure angle into radians. The next one that we're going to have in here is going to be the base radius. And again, I like really obvious ones. The base radius is going to be equal to our pitch radius. And then we are going to multiply by the cosine of our pressure angle, which we call alpha. Now we are going to put in our addendum. And the addendum, or the minor radius, this is going to be equal to our pitch radius, and then we are going to subtract the module times 1 plus 0.25. We're doing this in here just instead of writing just 1.25, just to make that a sort of a place where you can change the factor that you're using for the module and the size of the addendum. Now let's do the, oops, extra line here. Let's now do the addendum. And the addendum is going to be equal to the pitch radius plus the module. Now we are going to calculate the addendum diameter. And this is where we're actually going to drive an equation from our sketch by the value. Let's select our feature, and the addendum diameter is actually going to be this D0 dimension, and this D0 is going to be equal to the addendum times 2, because our addendum is actually the radius, and then by multiplying this by 2, we're going to end up getting the diameter value to drive our main protrusion. Let's also write a relation for the face width. And this one is going to be the D1 dimension, and this is going to be equal to that thickness parameter that we created earlier. If you use this button here, you'll be able to select the parameter from the list of available ones. So we will insert selected, and that way we have that one in there. Now we're going to do a couple for the radius tooth position, or the radial tooth position. And the radial tooth position, this is going to be equal to our base radius minus our module times 3 divided by 2, and our radial tooth height, again, I'm using really long ones. I don't even know what the character limit is here. Hopefully I'm not going to get past the maximum number of characters. And this is going to be equal to the addendum, can't spell today, minus the base radius plus the module multiplied by 5 divided by 4. Later on, because of the nature of the way that this geometry is created, unfortunately, we're not going to be able to do a pattern of the tooth that we create. We're actually going to copy the tooth using copy and paste special, and then we're going to pattern that particular one. And so we're going to create a couple of different angle values. And the first is going to be for the copied tooth. Call this the copy angle. This is going to be equal to 360 degrees, divided by the number of teeth. And also, we're going to use when we pattern these, we're going to have a pattern angle, and the pattern angle is going to be equal to the copy angle. So this is good. Let's hit the check mark to verify our relations. Everything has been verified. And if we take a look at the local parameters down here, you'll notice that we ended up creating a whole bunch of other different values. So this is good. Let us click the OK button to complete out of here. I'm just going to check some of the names again, just want to make sure what I'm calling things. So I'll click the OK button. The next step that we're going to do is we're going to create a curve using an equation, and I have a video that shows how to do this as well. We're going to go to the Datum overflow menu and then choose curve and curve from equation. Instead of using Cartesian coordinates, we're going to use cylindrical coordinates. You'll notice the reference tab is in red because it wants to know what our reference coordinate system is going to be. We're just going to select the part coordinate system. Let's click on the equation button. And you'll notice that the parameters are r, theta, and z. Those are our coordinates. And you have this independent variable t, which is going to go from a value of 0 to 1 over the length of the equation. And the first thing that we're going to do is we're going to calculate an additional quantity, gamma. And this is going to be equal to 2 times the arc sine of the thickness times the tangent of beta divided by 2 times the pitch radius. And now we're going to calculate our z coordinate. This is going to be equal to thickness times our t, independent variable for the equation, minus 0.5. Let me move my mouse over. Our radius value is going to be equal to our pitch radius. And the angle theta is going to be equal to gamma that we just calculated times the independent variable t minus 0.5. And let's verify our relations. I have an error. I forgot that I changed beta to my bevel angle. There we go. Let's verify now. There we go. Fixed my relations in there. That's good. I was missing another closed parenthesis for my arc sine equation. Let's click the OK button. And there you can see our curve. Let's hit the check mark. Let's regenerate. And there we have our curve that we're going to use. And this is going to be one of our curves that we're going to use later on for our variable section sweep that controls the helical shape of the tooth. To help define the shape of the tooth, we're going to do a variable section sweep. But before we do the variable section sweep, let us start out by sketching our one of the trajectories that we're going to use for this. So let's click on the sketch tool. I'm going to sketch on the datum plane called front. And we are going to have the datum plane called right face the top of the screen. That's good. Let's click on the sketch button. I'm going to go to my sketch orientation. And let's also go to a no hidden line mode, which will make it a little easier to see in here. I'm going to hold down the right mouse button to get to my sketch references so I can add in that curve from the equation as a sketch reference. Let's now put in some center lines that will help us sketch the geometry. I'm going to snap into the center there and also there. Let's create a couple of center lines that are perpendicular. And right now I'm just locating out some distance, and later on we will control this particular dimension here. I like this dimension, so I can select it and then from the mini toolbar choose to make it strong. And later on we're going to calculate the value of this. We're actually going to drive this from one of those parameters that I created a moment ago. And the only geometry that we're going to have in here is just going to be a vertical line. Let's sketch it along over here, just some random distance. And we have a dimension suggested for the angle between the endpoint of the line that I just sketched and one of our sketch references. Let's create a dimension for the length of the line itself. And again, it's got some value. That's okay because we're going to add in a relation in a moment. So this is good for this trajectory. And it's pretty neat how we're going to create the shape of the tooth using a variable section sweep. But for now, let's hit the check mark to get out of here. Let's go to our relations. And I'm going to add in a relation for the two different dimensions that we have in here. So let me go down here. And first off, we have our D4 dimension. This one is going to be equal to insert parameter, and this is going to be the radial tooth position. And the other dimension that we have here, the D5 dimension, this is going to be equal to the height of our radial tooth. And again, let's put in a comment line to explain what this is doing in here. Let's hit the check mark. They've been verified. I'm going to click the OK button out of here. Let's regenerate. And it got updated. I'm going to change over to a let's go to a wireframe mode for a moment. Just want to show you that the line actually extends into the part. And so let's go to Tools, and I'm just going to click on this and hit the Edit Dimensions. You can see that right now we've got a value of 24 and some change, and this is almost a length of 11. So this is good for this trajectory that we are creating. Now let's create a variable section sweep. And so we're going to go to the Model tab. Let's click on the Sweep command. Here is the button that makes it a variable section sweep. We're allowing the section to change. For this particular one, we are going to generate this as a non-solid surface feature. And this curve that we just created, this is going to be our main trajectory. Now for our sketch, we are going, before we do the sketch, I'm going to change the references here. For our section plane control, instead of using normal to trajectory, we're going to be doing the normal to the projection of our sketch onto the datum plane called front. Now we can click on the sketch button to go into sketch mode. And I'm going to use the InGraphics toolbar in order to change to my sketch view. Let's now add in a sketch reference of this over here. Click the Solve button. I'm going to put in a center line because we're going to sketch a line that's going to be symmetric about over here. Click on the line, and I'm just going to let it. I wasn't snapping to symmetry. So let's try to put in our symmetric constraint manually. There we go. We have this one dimension over here for the width of the line. What we're going to do is we're going to use some relations that are going to drive the shape of this feature along our trajectory so that it's going to look like a tooth. And this is going to be a little complicated, but it will be actually pretty cool when you see what is done. Let's go to Tools, Relations, and inside of here we're going to start out with a new local variable, ry, and this is going to be equal to our base radius minus the module plus trajpar, which is the special trajectory parameter, which goes from a value of 0 at the beginning of our trajectory to 1 at the end. And this is going to be trajpar times the addendum plus the module divided by 8 minus the base radius again minus the module, which again is essentially the tooth size. And that's a little complicated there, so I'm just going to go and hit this for a second just to make sure I didn't make any typos like before. Now we're going to calculate another value in here, which essentially is going to be used to drive the width of the dimension of that sketch. We're going to call it SG, and this is going to be equal to 2 times the base radius times pi divided by 2 times the number of teeth plus, hit the wrong button, plus the involute of the pressure angle, which we call EV alpha. All right, so let's see. Let's do a close parenthesis there. That's good. Now we're going to use something interesting. We're going to control the size of that dimension using an if-then-else equation. And so we're going to do that if ry, that local variable that we calculated, is less than our base radius, then we're going to assign to the dimension. I like to use some spaces in here. Here's our SD3 dimension, the width of that. SD3 is going to be equal to that ry that we created times SG, the other local variable, divided by our base radius. And then else, we're going to calculate alpha y is going to be equal to the arc cosine of the number of teeth, times the module times the cosine of alpha divided by ry times 2. All right, and let me see, looks like I need another close parenthesis. Then we're going to calculate EVy is going to be equal to the tangent of this alpha y that we just created minus pi times alpha y divided by 180, which again is sort of a conversion of that angle into radians. And then our dimension SD3, this in this case is going to be equal to 2 times the base radius times pi divided by 2 times the number of teeth plus EV alpha, tell you this is complicated, minus EV y. And then we're going to put in our end if to close our if then else construction. All right, so again, there was a lot over here. Let's try hitting the OK button. And now we're going to go back to the sketch tab over here. Let's hit the check mark. And you'll see again, with that complicated relation, we're going to end up with this surface being generated over here, which is going to be the shape of our tooth. And so again, the big thing is in our variable section sweep, we have our main trajectory, we have a straight line, and we have that complicated set of relations that basically says, hey, this is going to be the width based on that calculation until you get to a value of the base radius, and then it's going to use that other complicated calculation in order to figure out the width of the tooth as it's going to narrow down. So again, bit of some complicated relations, but let's hit the check mark, and I'm going to change over to a shading with edges mode so that you can see again, this is going to be the essential shape of the tooth that we are going to use. All right, now we are going to create a variable section sweep that is going to make essentially a sketch based on this shape over here go along over there. But before we do that, we need to create another trajectory. So let's click on the sketch button, and we are going to sketch on the datum plane top. And then just click the sketch button. Let me go to our mode over here. So again, this is going to be our X vector that we're going to use in our variable section sweep. This is going to be the section for our main trajectory. Let's just add in some references for the top and the back face of the disc. And our shape is just going to be a vertical line going from here to here. Now the order in which you do it does influence which is the start and end of the trajectory later on. But if you start off your variable section sweep and it is going in the wrong direction, you can just click on this pink arrow here to change the direction that the feature is going to go. All right, so this is good. For this one, we are going to now choose from the References tab. We're going to hold down the Control key to add in this other trajectory. And for our second trajectory, instead of using automatic horizontal vertical control, we're going to choose X trajectory. And it's automatically going to create that other one as our X vector. For our sketch, let's click on the sketch tool. And we're just going to use the project command to grab all the edges of that surface. We'll use the loop option, pick in the middle of the surface, and that way it grabs all the different entities. Let's close there. Let's hit the check mark, and let's change this to section unchanged. So that way it allows it to travel along the X vector over there, and you can end up seeing the helical shape that we're going to end up generating. Let us hit the check mark, and I'm going to hide this sweep surface here. Actually, before I hide it, let's rename this. That's the tooth shape sweep, and I like to rename my stuff so that other people understand what's going on over here. Let's just rename a couple of these different ones, and this is going to be the tooth sweep. Let's hide this surface over here because we no longer need it, and also hide some of our other different curves in the model. All right, so we have our first tooth in here. Now what we need to do is to use that copy and paste special in order to make the next one, and then we're going to pattern that one because, again, for some reason we're not able to just take this one and pattern it. So I'll just do copy and paste special, and we'll do a dependent copy, but we're going to apply move and rotate transformations to the copies. Let me click the OK button, turn on our datum axis display. Let's change our option from translation to rotation, and then pick the axis around over here, and I can drag it out. You know, we essentially want it to be 20 degrees, but we're going to have it being controlled by our parameter that we created. Let me double click on here, and I believe that I called that the copy angle. If I called it something different, I get an error, but no, it recognizes and says, hey, do you want to add copy angle as a feature relation? We'll say yes for that and hit the check mark. So there is the other tooth that is created. And with that tooth still selected, we're going to right click on here and choose to do a pattern. And we're going to pattern using this one over here. And this one, we could use copy angle, but I'm just going to use pattern angle. Hit the enter key. Yes, we want to add that as a feature relation. So there's the additional instance being created. We're going to just make this a number over here, just get a few previews of them in here. But what we actually want to do is have this also driven by a relation. So we will go to the model intent overflow menu, go to our relations, and add in some relations to control the number of teeth in the pattern. And we're going to write this as, let me just move everything over. I'm going to select the pattern in the model tree so I can see what the name of the dimension is, and the number of instances in the pattern is controlled by P21. And this is going to be equal to our total number of teeth minus 1, because we created the original tooth and then we use copy and paste special to generate it. So this pattern needs to have the total number of teeth minus the original one in there. So let's click the OK button. I forgot that I changed the name of my parameter to teeth. Verify, yay, everything is good. Click the OK button, click OK, and regenerate. And so in that way, we have our gear with the helical teeth in here. And a couple other extra things that I'm going to throw in here. Let's say I want a hole going through the middle of my part. Let's use the hole tool. And I'll select the surface and then hold down the control key and select the axis. And for the depth, I'll just choose 2 next. I'll use that diameter of 20 and hit it in there. And let's say that I want to put in a keyway to have this securely affixed to something. Let's create a sketch on this surface. I'll hit the sketch button. Let's go to our sketch view. For my references, I'm going to add in the cylindrical surface here. And for the shape of my keyway, I'm just going to use the center rectangle tool. Let's drag it out over here and use a dimension value. I'll put in 4 there and then hit the check mark. And now we can extrude our rectangle. Let's flip the direction. And I'm going to change the depth option to selected. I got to that by right-clicking over the drag handle and pick the back surface. And here we have it as a keyway right now that is adding material. If I wanted to, I could choose remove material, and this will end up being a cut, depending on which way that I want to go with that. So in that way, I have my helical gear created with my mounting hole and my keyway in there. I hope you enjoyed this video. For more information, please visit www.creowindshield.com. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button to be informed when new videos are uploaded. Thank you very much.